Okay, this is notes 10, page 7. I may or may not have gotten to this page in class, so I got this video here just in case. We are factoring with patterns. So, go ahead and try this one. Pause the video, give it a shot. Turn it back on when you've got it done. I'm going to go ahead and do this one. It's really quite simple, but it's a problem that students often make a careless mistake with. So, there's no GCF. Is there a pattern? Well, I have two terms, and it's a difference. Are they both perfect squares? Well, I can identify the square root of 9, that's 3. I can identify the square root of this term, that's x. Yes, they are both perfect squares. So this is the difference of two squares. So it factors as the square root of the first term. That has to go first in both factors. And then in one of them, it'll be plus the square root of the second term. The other one, it will be minus the square root of the second term. It will not matter which you put first, the plus or the minus here. The common error is to just flip this around and write this as x minus 3x plus 3. No. You can't flip it around. If you multiply this out, you get x squared minus 9, and that is actually the opposite of what you started with. So be careful. If the variable is in the back, then it needs to go in the back of each of your factors. All right. I'm going to quickly go over this one, just talk you through it. I went ahead and did it because I knew I wouldn't have time in class. GCF, yes, 2x. So you take out your GCF, which this is a pretty simple problem, taking out the GCF, so hopefully you're all good there. Don't stop just because you did one step in factoring. You might be able to factor some more. So we look inside these parentheses and we notice, wait, this could come from FOIL. But wait, again, wait, there's more. These first and last terms are looking suspiciously like perfect squares. In fact, they are. I can identify the square root of 9x squared, that's 3x. I know the square root of 25 is 5. Now, that is not enough to ensure it fits the pattern. What I have to do, and I'll do it off over here, got a little bit more space, take the two square roots I found, multiply them together, 15x, double that to 30x. Is that what I'm seeing here? Yep. If it fits the pattern, you don't have to think about it. It means you'll have one factor that's the same twice, so it's going to be the square of this factor. And what will the factor be? Well, the first term in the factor will be the square root of the first term, so it's just 3x, plus the square root of the other term, 5. Done. So the beauty of the patterns is once you recognize it fits the pattern, you got it factored. All right, so pause this video to try this one. I'm being a little mean to you right here, a little tricksy. Okay, so I'm going to go over this. GCF, no GCF. I do see that quadratic form. A squared, quadratic term, linear term, constant. And maybe there's a pattern. Well, because the square root of a squared is a. Square root of 36 is 6. But if I multiply the two square roots together and then double that, I get 12a. Not what's sitting there. This is not a pattern. That doesn't mean you can't factor it. It means you got to basically use guess and check. Well, I know it's a and a. I know they're both minus because the middle term's negative, but the last term's positive. Lots of options for 36. you know, like 3 times 12. It can't be 6 times 6, or that'd be the pattern. Oh, how about 9 times 4? Oh, yeah. Because outer is minus 4a, inner is minus 9a, adds up to negative 13a. That's it. Okay, so be careful with that perfect square pattern. The middle term has got to be just right, or it's not the pattern. Okay. Now, for the next problem, I'm going to give you some hints, and then I'm going to ask you to try this. The instructions are to factor, okay, not to multiply out. So I don't want you squaring this binomial. That's not, you're going to be creating more terms. When we get done, when we factored, we want this all one term. So, is there a GCF? No. Is there a pattern? Think about this. Think about this. Okay, one more big hint. I'm going to say that 2m minus 5 is a kitty. And I'm going to say that m plus 1 is a birdie. Now, is there a pattern? So pause the video, see if you can factor this. All right, so I'm going to go ahead and do it. Now, you don't have to introduce kitty and birdie. Those just help me see what's going on, because what I see, the square root of kitty squared, oh boy, it's getting late. That's the ugliest kitty ever. It's just plain old kitty. The square root of birdie squared is just birdie. And when you factor using the difference of two squares, because this is definitely the difference of two squares pattern, it's just use the square roots. So this would be kitty plus birdie. It's getting worse, isn't it? Give kitty some eyes. And then it would be kitty minus birdie. That kitty's not so bad. Kitty minus birdie, okay? That's how this factors. Now what I need to do then is go ahead and fill in what kitty and birdie are standing for. So this would be 2m minus 5 plus m plus 1. Now, I don't need parentheses here because addition is associative. If I had them around the m plus 1, it wouldn't change a thing. However, the next factor is different. This is kitty minus all of birdie. So I absolutely need parentheses around that. Okay, so that's kitty minus birdie. Now, when you use some little shortcuts like this, you get factors that look like a mess. We can clean these up. We can simplify this factor. 2m plus m is just 3m. Minus 5 plus 1 is minus 4. Now here, I have to distribute this negative. So this is 2m minus 5 minus m, minus 1. Okay, and then finally this factors as 3m minus 4. 2m minus 1 is m minus 6. So that's the sneakiest way to do it. And you really, really want to start seeing patterns in a broader sense. When you get to trig functions, you'll see sine squared, cosine squared, things like that. So you want to be able to start picking up on patterns even when things look a little bit different than something as simple as 9 minus x squared.